Welcome to qnawire.
In this question, we are given a rod whose length is 30 centimeter. The mass of the rod is given to us 3 kg. On this rod, on the two side, as we can see, 20 Newton and 32 Newton force has been acted. We have to find what is the force exerted on this 20 centimeter part of the rod by the 30 centimeter part of the rod. Okay, so as the total length of the rod is 30 centimeter, we can write mass of 10 centimeter part, mass of 10 centimeter part, that will be as the 30 centimeter length is having 3 kg mass, so 10 centimeter part will have 3 into 10 by 30 kg mass, which will be 1 kg. So let's say this is my m1, the mass of the 10 centimeter part. Okay, similarly I can write mass of 20 centimeter part, that will be 3 into 20 by 30 kg, that will be 2 kg. Let's say this is my m2, this is m2. Okay, now the 20 centimeter part of the rod is going to apply a force on 10 centimeter part, that will be like a tension force, so that will be acting in this direction, that is F. And similarly on 20 centimeter part, the 10 centimeter part of the rod will apply a force that will be acting towards left. These two are action and reaction force, reaction pair we can say. Okay, then if we draw the free body diagram of these two parts of the rod, so let's first try to find what are the forces acting on this 10 centimeter part. So on 10 centimeter part, its weight will be acting downward, that will be m1g. A normal reaction force will be acting in the upward direction, that is, let's say, n1. And then due to the 20 Newton force, it will feel a force towards left, that will be 20 Newton. On the second part, which is m2, the force that will be acting due to gravity will be m2g downward. A normal reaction force will be acting upward, that will be, let's say, n2. And one more force will be acting forward, that will be due to the string, which is 32 Newton. Okay, and of course one more force is acting F, which is towards back due to the tension in the part of the rod. So if we draw the FBD of this 10 centimeter part, so we can write free body diagram of 10 centimeter part. Okay, so as we can see, if this is representing the 10 centimeter part, so on this 10 centimeter part, first of all, F force is acting forward, F force is acting forward, then 20 Newton force is acting backward, its m1g weight is acting downward, and the normal direction force, which is n1, that is acting upward. Now here you see, as on the whole rod, total 32 Newton, total on the right side 32 Newton amount of force is acting, on the left side total 20 Newton amount of force is acting. So the net force on the rod is not zero, so we can say that this rod is going to accelerate towards forward. Let's say the acceleration of the rod is a, so each part of the rod will have the same acceleration as it's a single object. So we can write that this m1 mass will go forward with an acceleration of a. Then I can apply the Newton's second law along the horizontal direction. I can write that the net force, which will be F minus 20, that has to be equal to m1g by, sorry, m1a. A is the acceleration of the rod in the forward direction. So this is by Newton's second law. Let's say this is my equation number 1. Similarly, I can draw the FBD, free body diagram, for 20 centimeter mass part, FBD of 20 centimeter part. So for this one, as we can see, suppose this is representing the 20 centimeter part, then on this, in the forward direction, 32 Newton amount of force is acting, 32 Newton. Towards left, F force is acting. Towards upward, N2, normal direction force, N2 is acting. Downward, M2G force is acting. And as a whole, the whole 20 centimeter part is moving forward. with an acceleration of a. So in this case, again, by applying Newton's second law along the horizontal direction, I can write the net force, which is 32 minus F, that has to be equal to m2 times a. So this is, let's say, my equation number 2. So using this equation 1 and equation 2, we can easily find the value of F. Okay, by adding equation 1 and 2, we will get 32 minus 20 is equals to m1a plus m2a. So from here I can write that 12 is equal to m1 is 1 kg, so 1a, that is a, plus m2 is 2 kg, so that will be 2a, so this will be 3a. So from here we can write the acceleration of the block or the rod is 4 meter per second square. So this is an useful information. Now using this, and from equation 2, let's say, we can write from equation 2, we can write that 32 minus F is equals to m2, which is 2 kg, into a is 4. So from here I can write that F is equal to 32 minus 8, which is going to be 24. So the force applied is 24 Newton. So this is the force which has been acted on the 10 centimeter part of the rod by the 20 centimeter part. So this is the answer for the question. Thank you.